Have you ever looked up at the night sky and wondered, are we alone? That simple question has fascinated humans for centuries, sparking our imagination and driving us to explore the cosmos. Every twinkling star could be a sun to its own worlds, each with the potential for life. That's the question at the heart of astrobiology, a field that seeks to answer one of humanity's oldest mysteries. Astrobiologists are like cosmic detectives, piecing together clues from astronomy, biology, chemistry, and geology to find out where life could exist. They study everything from the tiniest microbes to the vastness of space, searching for patterns and evidence that might reveal life's secrets. Sometimes the clues are hidden in meteorites or in the chemical fingerprints left behind by ancient organisms. Each discovery brings us a step closer to understanding our cosmic neighborhood. By studying how life began and evolved on Earth, we create a blueprint for what to look for elsewhere. Earth's history is like a guidebook, showing us the conditions that allowed life to flourish here. With billions of galaxies and even more planets, the odds seem good that Earth isn't unique. The universe is vast beyond imagination, filled with endless possibilities. Astrobiology turns our wonder into real, testable science, searching for planets with the right conditions for life. Scientists use powerful telescopes and spacecraft to scan distant worlds for water, atmospheres, and the building blocks of life. Finding even a microbe beyond Earth would change everything we know about our place in the universe. It would mean life isn't just an earthly miracle but a cosmic phenomenon. So let's dive into what makes a planet a home for life, and join the search for our cosmic neighbors. What does life need? It's a question that has fascinated scientists and dreamers alike for generations. When we look out into the universe searching for signs of life, we start by asking, what are the basic ingredients that make life possible? Astrobiologists look for three main ingredients: liquid water, the right chemical elements, and a source of energy. These are the foundation for life as we know it, and they're the first things we hunt for on distant worlds. Water is the universal solvent. Wherever we find it on Earth, we find life. From the deepest oceans to the tiniest droplets, water is essential for carrying nutrients and enabling the chemistry of life. It's the liquid highway that connects all living things. Carbon, along with hydrogen, nitrogen, oxygen, phosphorus, and sulfur, forms the essential building blocks. These elements combine in countless ways to create the molecules that make up cells, DNA, and all the complex machinery of life. Energy powers life. On Earth it's mostly sunlight, but some organisms thrive on chemical energy from rocks or vents. Whether it's the warmth of the sun or the heat from deep within the planet, energy sparks the reactions that keep life going. Put these together and you get a habitable environment. The Goldilocks zone, not too hot or cold, but just right. It's a delicate balance where all the ingredients can mix and mingle to create something truly extraordinary. This simple recipe guides our search for life beyond Earth. We scan the skies for planets and moons that might have these three key ingredients, hoping to find another place where life could take hold. We're looking for other cosmic kitchens where these ingredients might mix, blend, and maybe even cook up something alive. The universe is vast and the possibilities are endless. That's the recipe for wonder, a cosmic quest to discover if we're alone or if life's ingredients have come together somewhere else among the stars. Life on Earth is tougher than you think. From the deepest ocean trenches to the driest deserts, our planet is home to organisms that can survive in places where nothing else can. These remarkable life forms have evolved to withstand conditions that would be deadly to most other creatures. Extremophiles, organisms that thrive in extreme conditions, show us just how adaptable life can be. They flourish in boiling hot springs, acidic lakes, and even radioactive waste, pushing the boundaries of what we thought was possible for life. At the bottom of the ocean, near hydrothermal vents, creatures survive without sunlight, using chemical energy instead. These vents create an alien world, where tube worms and strange microbes form entire ecosystems in total darkness. In the Atacama Desert, one of the driest places on Earth, microbes live inside rocks, protected from harsh radiation and dryness. They find shelter in tiny cracks, drawing moisture from the air and clinging to life where almost nothing else can. Even in Antarctica's buried Lake Vostok, microbes survive in total darkness and freezing temperatures. Trapped beneath kilometers of ice for millions of years, these tiny organisms have adapted to a world without sunlight or warmth. These extremophiles expand our imagination for where life could exist. maybe beneath the surface of Mars or on icy moons like Europa and Enceladus, where liquid water might hide below thick layers of ice. They prove that life can find a way in the most unlikely places, adapting to challenges that seem impossible to overcome. Their resilience inspires us to look for life in the most unexpected corners of the universe. On Earth, the rulebook for life is always being rewritten. Every discovery of a new extremophile teaches us that life is more flexible and inventive than we ever imagined. And that's our guide for searching other worlds. If life can thrive in Earth's harshest environments, who knows what we might find out there? With our blueprint for life, we start our search in the solar system. Mars, once wet and possibly habitable, is being explored by rovers searching for signs of ancient life. The real surprises, though, are icy moons like Europa and Enceladus. Europa likely hides a vast ocean beneath its icy shell, kept warm by Jupiter's gravity, maybe with hydrothermal vents like Earth's. Enceladus shoots plumes of water, salt, and organic molecules into space, hinting at a subsurface ocean. These moons have water, chemistry, and energy, making them prime candidates for life. Our robotic explorers are on the hunt for biosignatures, the fingerprints of life. The search is just beginning. Astrobiology isn't just about aliens. It's about understanding our origins and our place in the universe. Searching for life pushes our technology and imagination, inspiring new generations of scientists and engineers. Even finding a microbe elsewhere would prove life isn't unique to Earth, changing science and philosophy forever. The quest connects us all in wonder, reminding us how precious and rare life might be. Every rover, every telescope is a step in humanity's greatest adventure. Astrobiology teaches us to be curious, to ask big questions, and to cherish our home planet. The universe is waiting to be explored. Let's get to it.